Hello guys, welcome back. So we have implemented our quick sort in the last lecture. So in this lecture, let's quickly walk through the call stack of the quick sort in this lecture. Okay. So in case if you are not understood how it is working internally, then this lecture will help you understand it completely, right? So for that we have to keep it running, and then for this one I'll just keep the array smaller because I don't want it to run like multiple call stacks, right? So 2, 1, 9, 8, 4, 6. Let's move 4 and 6 here. Okay. So this looks a little bit unsorted now. Okay. So let me just remove these things. Okay. So let me just quickly, or yeah, this is fine. Okay. So let me just simply open the uh, inspect tab, where sources tab. Okay, so here I have to go into the scripts. I have to detach it, then yeah, this will be fine because here you guys can see completely, right, what's going on. Okay, so I have to go at the very bottom. Yeah, here somewhere it will be. Okay, so I'll add one debugging point here and I'll add one here. Okay, now let's see how it goes, right? So what we have to do, we simply have to reload the page, right? Or for that, let me just quickly reload it here. Okay, so it came here now. Now as you can see, we have the call stack here as well, right? So just forget about the script, we have the call stack. And here we have anonymous because we haven't executed this thing yet, right? So let's walk through it. Okay, so I came inside the quick sort algorithm. Okay, so in call stack, as you can see, you guys can see, right? I think so. Okay, so as you can see in call stack, we have an execution context of quick sort. Okay, so here there must be some scopes or something. Okay, so right now the array is 462198. Okay, and that is what we are getting here, 462198. That is totally fine. Since the start is smaller than end, it is going to go inside this function. So let's step inside this. Okay, so it is satisfying this condition. End is basically array dot length minus 1, so obviously it's 5. Start is by default 0. So in helper pivot, what will happen now? We are passing the array and then we are passing the 0 start index basically, right? So now if you go inside this, then what this helper pivot will do, it will basically pick a pivot number and then it will swap the index, right? That is what it is going to do, right? So let's see. Array at position start index is 4. So basically we are picking the start number from the pivot, start number from the array as a pivot number, right? Now we are going inside this for loop. Let's see what happens. Okay, so here start index plus 1, because obviously we have to ignore this 4. We have to check these numbers, right? So yeah, array dot length, and then it came inside this pivot is small greater than array at position I, right? So let's see if this condition satisfies. Array at position I, so I is 1, so 0 1. Array at position 1 is obviously greater than 4, right? So we are incrementing the swapping index by 1. So let's see what happens. Okay, so I plus plus. Okay, so we did the I plus plus. Okay, from swap index we have incremented from here, and then we are swapping those elements, basically 4 to 6. So now 6 will be, okay, 6 will be here and 4 will be here, right? Because this is a greater number. Now we have checked 2 is smaller than 4, right? So this is the number which we are going to swap. Swapping index is 1, 0, 1. Okay. And pivot is 4, I is 2. Okay. So current is 0, 1, 2. Current index is 2, swapping index is 1. That means these two numbers we are going to swap. Now if you remember like how it works, how quicksort works, whichever is the first largest number in the array, it will get swapped with the smaller number which we find, which is smaller than the pivot number, right? So this number is greater than the pivot, and this number is smaller than the pivot and smaller than the largest number here, right? So these two numbers we are going to swap. Okay, so let's see how it goes. So it came inside the swapping index, array at position index 1 is 6, and then it's basically that simple swapping logic, right? Okay, so now as you can see, our array is swapped. Those elements are swapped in their position. Now 2 is here and 6 is here. Okay, and this is how we basically gather all the small numbers together and all the large numbers together, right? So yeah, now again it came back to this helper pivot function, because it will keep on iterating through it, and it will keep on gathering all the small numbers together. Now it is in iteration, I guess. Pivot is 4, so index is 2. Okay, so it will go in the next iteration now. Okay, so now as you can see, index is 3. That means 0, 1, 2, 3. Index is 3. This one is also smaller than 4, right? Our pivot number, because of this condition. So what we are going to do, our swapping index is 1. So we will increment it by 1. So our swapping index will become this one, right? This 6. So now this 6 will get swapped with 1, right? So we will have 2 and 1 together. That means the smaller numbers, the numbers which are smaller than the pivot number together, and then the larger number together. Okay, so let's see how it goes. So again, the swapping and all those things will happen. Okay, so let me just quickly fast forward it. Okay, so as you can see, after swapping, we are getting 2 and 1 together. 6, 9, 8 are on the left side, right? Since all these numbers are greater than 4, so we are not going to change any of their sequence. Okay, so now at the last step, what we have to do, we simply have to swap 4 with the 1. Okay, then only we will get like smaller numbers on the left side and larger number on the right side, right? Simple helper pivot function thing, right? So let's see, we have the current index as 3. So let's move ahead. Okay, so now current index is 4, right? Where is that call stack? Okay, current index is 4, 0, 1, 2, 3, 4. Okay, so it will not do anything. Okay, so since the pivot is smaller than array at position I was 9. 9 was greater than pivot, so it never went inside this swapping old function, right? So yeah, okay, I think it will go inside this one at the end. Let's see, because see, as you can see, we don't have any other number which is smaller than 4, right? So it will check the condition and will move forward, right? So let me just fast forward it. Okay, so after coming out of this for loop, we are again swapping the indexes, right? The start index is 0 because that is the one which we have stored as a pivot number, right? Now the swapping index we have as 2. So 0, 1, 2. So this is the smaller number, last smaller number we can say than the pivot number. Okay, so these two numbers we are simply going to swap. Okay, and then we will have all the numbers smaller than 4 on the left side and all the numbers larger than 4 on the right side. Okay, so now it again went inside this swapping logic, and then as you can see, we have successfully swapped it, right? Now, now this thing will return the swapping index. So we have swapped 4 from the 0th index to 2nd index, right? So now we will return 2 as the swapping index. So this is the index where we have the pivot number, and then all the elements, smaller elements are here and all the larger elements are here, right? So let's play it. Okay, so now since we have the pivot index here, what we are doing, we are again calling the quicksort, right? And here we are passing the array. Okay, and here the start index is obviously 0, and end index is pivot index, that means 2 minus 1. So 0 1 2, 2 minus 1, that means we are going to take these two elements now. Okay, and then we are going to call this quick sort with that array. Okay, so let's see how it goes. Okay, so start is obviously greater than end is our 1, that means 0 and 1, these two numbers basically. So it is satisfying the condition, so it will go inside this. Okay, and I'll quickly add a debugger here because I don't want to like run this same thing over and over again, right? Because if you understand in the first step, that means you are going to understand in all these steps, right? Okay, so now as you can see, yeah, one more thing I wanted to add. Since we have called another quick sort, that means we have added another execution context in the call stack, right? So that you have to keep in mind. So if I click on this, okay, so for this variable pivot index, everything is pivot index is undefined, right? But for the older one, we have the pivot index as 2, right? Because from here we have returned the pivot index, but here we haven't yet returned anything from the helper pivot, right? So that is why pivot index is undefined. Okay, so whichever block you are seeing right now is the latest execution context or latest function calls execution context. Okay, block, we can say local variables and everything. This whole thing is a scope of that particular execution context, right? So let's see. Okay, it again went inside this, so let me just quickly play directly. Okay, so now pivot index is 0, our array is again the same, start index is 0, pivot index 0 minus 1, it is, this condition is going to fail again, right? See, since the pivot index is 0, okay, so start and end, these are going to be 0 only, right? So 0 minus 1, it is going to be, this one is going to be minus 1, right, if I'm not wrong. So if I played, so now the start is 0, end is minus 1. So it is not satisfying the condition, right? So what will happen? It will simply return the array, right? So let's see. Now in the array, what we are returning? 1, 2, 4, 6, 9, 8, right? That means whenever the condition is not satisfying, it will simply return the array. Okay. So quick sort here, we will have 1 to this thing. So let's quickly add a debugger here as well. So now we'll just ignore this one. We'll just keep an eye on this how this thing is working, right? So let's play it. So now it went inside the second quick sort. Here pivot index is 0 plus 1. Okay, and index is 1 again. So let's see. Start index is 1 and index is 1, so it will not go inside this. Again it will return the array. Okay, because here I think what we are going to get, let's see. So array is this, end index is 1, start index is 1, so 0 1, basically this element. Okay, so that means we are going to return the array directly. Okay, so let's play it once more. Okay, so now again it is going inside the quick sort in the second one. Okay, where we are checking the right side of the pivot index, right? So pivot index is 2, right side, that means this part of the array. Since we have the elements, okay, where the start index is more than end index, so it will keep on calling these functions, right? So let's see. Start index, again we have called this function. Start index is 3, end index is 5, that means start index 3, so 6, end index is 5, which is 8, right? So let's see how it goes. So here we will get the pivot number. Pivot index is 3, so pivot index 3, that means we have 0 1 2 3, 6 we are taking as a pivot number this time. Okay, and the logic which we have seen, the working which we have seen for this whole array, where we have picked 4 as the pivot number. Okay, and then we have moved all the numbers on the left side, small numbers, and larger number on the right side. Same thing is going to happen for this smaller array now. Okay, as you can see, start is 3, end is 2. Okay, so that means start is greater than end, so it will simply return the array. Okay, this time. So let's play it. So here we are going to get something in return. Okay, now end is 5, start is 3, pivot index is 3 plus 1 4 and index is 5. Okay, so pivot index is 3, right? So this time we are going to take these two elements. Okay, so we have took these two elements and then again we are calling these two elements since because of this logic, right? So now here we will have these two numbers where the start index is 4 and end index is 5. That means it will satisfy this condition, right? So it will go inside this block, it will pick out the pivot, like it will pick out the pivot index, it will sort that element in the array and it will return the pivot index, and then it will call quick sort again, right? And there, if the start index is not smaller than end index, then it will simply return the array. That is the idea, right? So now start index we have 4 and index we have 5. It will go inside this one pivot index. Let's see what we are getting. We are getting 5. Okay, so pivot index is 5. That means 0 1 2 3 4 5. That means 9 is the pivot index right now. So start is 4 and pivot index minus 1. End is going to be pivot index minus 1. That means 4, right? Because since we have picked this one as the pivot number, okay, so we are going to ignore this number, right? If you think we have to ignore this number always, right? Whichever number we are picking as a pivot, we have to ignore that number, right? So in the first half we have to pick all the numbers which are smaller than, which doesn't include this number, right? And in the right side we have to cover all the elements which doesn't include this number. So right now if we ignore, like if we omit this number from the array, then what we will have? Fourth element. That means just 8, right? So now here the end index will be 4, start index will be 4. So at the end what it will return? It will return the array because it will not go inside this condition again, right? So if I play it, as you can see, start index is 4, end index is 4, right? That means it is not going inside this block and it is returning the array. Okay, so let's see how many call stacks we have here. So we have 1 2 3 4 call stacks, execution context, right? Not call stacks, execution context. Okay, so now what is happening? It is returning the arrays, like returning the arrays from the execution context, right? It is returning out the arrays, so which will get stored here, and then it will like whichever function we have called previously, which is waiting for the values, right? They will get their values again. Okay, now let's go back to the last execution context. Let's play it. Okay, this one, I think this one I should collapse. Okay, so this one also I think we don't need, right? Because we have array, end index, start index, and script we don't need. Yeah, this is fine only. Okay, start index is 6 and index is 5. Obviously it is not going to do anything. It is going to return and the execution context for this will pop off. Okay, so as you can see, okay, so let it pop off the stack. So as you can see, we have 3 execution contexts now. Okay, so now this is how it is basically sorting the array every time, right? So here we have start index is 3 and index is 5 0 1. Let's quickly 3 and 5. That means it is back to the function which have passed this as the array, right? So now in this execution context, let's see what we are going to get. 6 8 9. Since all the numbers are on their correct position, so nothing is going to happen in this one, right? So let's see again. So the execution context of that also got popped off. Now we are simply returning the array, right? So 1 2 4 6 8 9. So basically sorting happened here, but nothing happened here since these elements are already sorted, right? So this is how the quick sort works in the browser. If you want to understand, you can add the breakpoints, you can step through all these steps, and then you will get the idea like what is happening at each step, right? So this video was especially for those who didn't understood, like in the previous lecture, how it is working, how it got sorted automatically. So this is how you can test it, right? So this is it for today's lecture. In the next lecture, let's see the time complexity and space complexity of quick sort, and then we will jump into the last sorting algorithm of this series, and then we'll move on to the data structures. So we have a lot more interesting things coming down the road, right? So yeah, this is it for today. See you in the next one.